Hey guys, Mr. Middleton here. Today we're going to talk about proving quadrilaterals are parallelograms. At the end of this video, you should be able to use the given information to say whether a quadrilateral is a parallelogram, and you should be able to justify why a certain quadrilateral is or is not a parallelogram. Alright, so last lesson we were given that a quadrilateral was a parallelogram, and we concluded certain things about the angles, the sides, and the diagonals. Today, we are going to do the opposite. Okay, we are going to be given a characteristic, and we're going to need to determine whether that information is enough to say we have a parallelogram. Okay, we'll go through a few theorems and show why they work, and then get some practice. So, first things first, theorem 1 says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if the diagonals bisect, then the quadrilateral is a parallelogram. We'll show this with a proof. Remember, guys, that though I'm showing you the proof, that I'm doing this to show you why it's happening or why it's true. This is not something that you'll necessarily have to demonstrate, but to understand why it works will further your knowledge and help you along this course. So, here's our proof. We're given that AC and BD bisect each other. We want to prove that ABCD is a parallelogram. I'll just draw that here. Okay. So what we need to do is we need to show both pairs of opposite sides are parallel. Remember, that's our definition of a parallelogram, is that both pairs of opposite sides are parallel. Alright, so with just the information that the diagonals bisect each other, let's go through this proof. Alright, so we'll start with the given information, and the given information was AC and BD bisect each other. Okay, and that's given. From there, because those two diagonals bisect, then we can say that they cut each other in half. That's what bisect means. So I can say that AE is congruent to CE, and the same logic, I can say that DE is congruent to BE. And that's the definition of bisector. Okay, and those are already marked for me. Alright, I'm trying to prove that I have two pairs of parallel sides, and so in order to do that, I'm really going to have to work some angles. Okay, when I think of parallel lines, I think of alternate interior angles, corresponding angles, same side interior angles, and so I'm going to have to kind of search for those here. And I really do see them. We're also going to have to use some triangle congruencies as well. So what I see is that this triangle ADE and this triangle CBE should be congruent, and I can prove that. I can do that first by looking at our vertical angles, and I can say that angle AED is congruent to angle CEB because vertical angles are congruent. I can just say vertical angles. I'm going to mark it here. Okay, now that I see that, I can tell that these two triangles are congruent. So triangle AED is congruent to triangle CEB because of side angle side. So these two triangles are congruent. Now that helps me now because I can say, since those two triangles are congruent, these two angles are congruent. I can say that angle DAE is congruent to angle BCE because of CPCTC, corresponding parts of congruent triangles are congruent. Okay. These angles are alternate interior angles. Okay, and so I can say that AD must be parallel to BC because of the converse of alternate interior angles. I'll just say converse of AIA. Okay, so from here to here, we were proving that these two lines are parallel. AD parallel to BC. Okay. So really half our work is done because we wanted to prove that both pairs of opposite sides are parallel. And so I'm going to be doing that really the same steps in order to prove that AB is parallel to DC. Really, yeah, almost exactly the same. So I'm going to step in here. I'm going to look at these two triangles, and I can say that angle AEB is congruent to angle CED because of vertical angles. From there, I can say that those two triangles should be congruent. So triangle AEB should be congruent to triangle CED because of side angle side. Okay, I'm trying to prove these two lines are parallel, so I'm going to look at this angle here, 1, 2, 3. This angle here, 1, 2, 3. Those two angles should be congruent. So as I name them, EDC, or I'll say EBA, angle EBA should be congruent to angle EDC, again because of CPCTC. And so I can say that those two lines should be parallel. AB is parallel to DC. Because of the converse of alternate interior angles theorem. Alternate interior angles theorem. And because of that, I can say that ABCD is a parallelogram, and that's because of the definition of parallelogram. Two pairs of opposite parallel sides. Alright, so again, it's not necessarily true that you'll have to prove this, but to understand why it is always true will help you out. Okay, so we know that if we have, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Alright, so that's the first theorem. We don't have to go through proofs for all of them, but that one's in the books. Theorem 2, it says if one pair of opposite sides of a quadrilateral is both parallel and congruent, parallel and congruent, then the quadrilateral is a parallelogram. Okay, it says draw a parallelogram to show this theorem. You might be better to construct it, but I'm just going to draw it here. Okay, so if I draw 3, actually that's 2. Okay, I'll try to keep the paper straight so that works out. Okay. Alright, so this is kind of a freehanding to try to make it same here. Okay, so these are parallel. They're both 2 inches long, and so these are the parallel sides. Now, the reason I draw it like that is if these are parallel and congruent, then what I'm going to have to do in order to connect these into a polygon is that I'm going to have to draw, again, parallel and congruent sides that finish it. Okay, and so what that will do is we'll have 2 pairs of opposite and parallel sides. So the fact that this this side was both parallel and congruent will force the other 2 sides to be, again, parallel and congruent. And those are the properties of parallelograms that we talked about in our last lesson. Theorem 3. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, again, what that does, in order for both sides to be congruent, that means that we have to have the properties that we talked about previously. Okay, so if that's an inch, and that's an inch. Try to make them so that I'm trying to make it so it works out. Forgive me if I mess up on my angles. I'll make that an inch. I feel like I closed in too much on that. Let's see if this will be an inch. Hey. Sweet. Cool. Alright, so I have it so that these two are congruent to each other. These two are congruent to each other. I guess they're all the same in my drawing. But again, it doesn't change that both pairs of opposite sides are congruent, and therefore it has to be a quadrilateral. Or sorry, a quadrilateral is 4 sides. Therefore, it has to be a parallelogram. Okay. Theorem 4 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, draw a parallelogram that shows this is theorem. It's going to be harder for me to show that in this case, but what we'll see if we have a quadrilateral. Drawing a quadrilateral. All right. These opposite angles. Okay, this is what you'll be looking for in these markings. Okay, both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Okay? Alright, so with that, straighten this paper up, do some practice problems. Okay, so those are the 4 theorems that you'll need to know. The diagonals bisect each other. It's a parallelogram. If we have one side that's parallel and congruent, then the quadrilateral is a parallelogram. If both opposite sides are congruent, it's a parallelogram, and if both pairs of opposite angles are congruent, then it's a parallelogram. All right, so this practice problem says find the value of the variables that would make the quadrilateral a parallelogram. Notice that the variables are written on the diagonals. So we can solve this problem by saying, okay, if this is a parallelogram, our diagonals have to be congruent. So 2y minus 7 has to equal y plus 2. And 3x has to equal x plus 5. Alright, so now these are the 2 problems that we would solve. We set this up based off our knowledge that the diagonals have to bisect each other if it's a quadrilateral. So we just solve these 2 problems. I'll subtract x from both sides. 2x equals 5. Divide by 2. X is 5 halves, or 2.5. Okay, either one. Okay, same thing for the y's. Subtract y from both sides. Add 7 to both sides. Y equals 9. And there's our solution. Okay, so if this were a parallelogram, y would have to equal 9, x would equal 2.5. Alright, so now we're looking at these quadrilaterals, and we're trying to see if there was enough information for us to say that the quadrilateral is a parallelogram. So for number 1, the answer is yes. Okay, we don't have to say by theorem 3, but theorem 3, I'm going to mark theorem 3 so I have to write less. But please understand it's because both pairs of opposite sides are congruent. Okay, theorem 3 at the top of our page. Okay, both pairs of opposite sides are congruent, and so it must be a parallelogram. Number 2, the answer is no. And number 2, what it was really trying to go for was the second theorem we talked about, in the sense that we had one pair that was both parallel and congruent. But here in number 2, they don't show us that. They actually just show us that we have one set of parallel lines, and then we have another set of congruent lines. Okay, even though this drawing doesn't look to be it, this is actually the definition of an isosceles trapezoid. So while this might be a parallelogram, the question is there enough information to prove that it's a parallelogram? And based off of the diagram, there is not. This could be a trapezoid. This could be an isotrap. Okay. Because we have, again, one parallel side, and then the non-parallel sides are congruent. Number 3, is this a parallelogram? And the answer is no. Okay, even though you have these markings and it almost looks like the diagonals bisect, notice that the diagonals do not bisect here, because if they did, this side would be congruent to this side. Okay, that would show that our diagonals bisect. This side would be congruent to this side, and they are not. Okay, so no, the diagonals don't bisect. And then number 4, is this a parallelogram? The answer is yes. Okay, and it's yes because we have parallel sides, and then they have this marking M for their length. So it doesn't matter what the length is, but that the length is the same. It's this theorem 2 where we have a pair of opposite sides that's both parallel and congruent. Alright, so there you have it, 4 theorems that you have to remember in order to prove that a quadrilateral is a parallelogram. See ya.